to have a look at what the complex conjugate is. So if I had a complex number, call it a z, which is equal to 3 plus 4i. It has a real part 3 and the imaginary part is 4. The complex conjugate is similar to the complex number. So the complex conjugate of z is written as z with a bar over the top of it. It's similar because the real part remains the same. It is still 3. And the conjugate part then is minus 4i. So basically all you do is you change the sign of the imaginary part. So if I had another one, just say it's w, and it's 4 minus 5i. Well, the complex conjugate for this, call it w bar, is going to be 4, as this is. But the imaginary part here, the minus 5i, changes sign and it becomes plus 5i. Here's another one, x. Okay, y. So if we have an imaginary number y and it's minus 3 plus 10i, then the conjugate of that will be minus 3. The real part stays the same, but the imaginary part will change sign, minus 10i. Now what's the advantage of this? Well, if we were to add the complex number and its complex conjugate, we would have a purely real number. So for example, if I was to add a z plus its complex conjugate, a z plus a z bar, the first one is 3 plus 4i, and now I'm going to add z bar to it, plus 3 minus 4i. If you add the real parts together, 3 and 3 is 6. But if you look at the imaginary parts, we have a plus 4 and a minus 4. So that's 0i. 0i, or basically 6. It is a real number only. Okay, I'll just do y. Plus y bar is going to be, y is minus 3 plus 10i. And then its conjugate is minus 3 minus 10i. So if I'm to add these together, the real part is minus 3 and minus 3 will give me minus 6. And the imaginary is a plus 10i and a minus 10i, which will be 0. Okay, so it's just 6. Then let's try the w. W plus its complex conjugate, w bar. So we'll have 4 minus 5i, and then the complex conjugate, 4 plus 5i, plus that plus for that plus, there, 4 plus 5i. So we have 4 plus 4 is 8, minus 5i plus 5i is 0. So that's the answer, 8. Right. So when you add complex numbers, or complex number and its complex conjugate, you will end up with a real number. Okay? Now, it's similar when you multiply them. So let's have a look. Have a look again. So multiply. And we're going to multiply a z times its complex conjugate, a z bar. So a z is actually, if I write it here, z is 3 plus 4i. Therefore its complex conjugate, z bar, is going to be 3 minus 4i. So let's multiply them. 3 plus 4i times 3 minus 4i. Again, you split up the first bracket. It's going to be 3 on 3 minus 4i, and then plus 4i on 3 minus 4i. Z times its complex conjugate. 3 3s are 9. 3 4s are 12. That's a plus by a minus will give me a minus and I. Now we have 4 3s are 12. Well, they're both plus, so the answer is plus, and we have the I, plus 12i. And next we have a plus by a minus will be a minus. 4 4s are 16. I times I is I squared. And this happens all the time with complex conjugates. We have a minus 12i here. We have a minus part and a plus part. Minus 12i plus 12i equals 0. and we're left with 9 minus 16i squared. But remember, I squared equals minus 1. So that is now 9 minus 16 multiplied by minus 1, which becomes 9, and minus by minus is plus 16. 9 plus 16, which is 25. Now, the part about this is two things to remember. When you multiply a z times its complex conjugate, you will get a real answer. The other thing to note is that we have 3 and 4 here. 9 is 3 squared and 16 is 4 squared. Okay? 3 squared plus 4 squared is 25. So let's have a go at another one and see if that happens again. Right, we had W, which was, so call this example 3. W, which was 4 minus 5i, and therefore its complex conjugate is going to be 4 plus 5i. And I will multiply them by each other. W times W bar. 4 minus 5i. Doesn't really matter once one is minus and one is plus. Times 4 plus 5i. Right. So let's split up the brackets. 4 on 4 plus 5i minus 5i on 4 plus 5i. So multiply them out. 4 4s are 16 plus 4 5s are 20i, and minus by a plus will give us minus. 5 4s are 20 times I, and then a minus by a plus will be minus. 5 5s are 25i squared. Now we have the 16 minus 20i and plus 20i will leave us with nothing. There, no i's, okay? And we still left over have here the minus 25i squared. Then again, the I squared is actually minus 1, so that's the same as 16 minus 25 multiplied by minus 1, which is 16 minus by a minus plus 25. Note, the 16, 4 squared, and the 25 is 5 squared. 16 and 25 is 41. So W times W bar is 41, which again is an element of the real numbers. It's real. You're right. 5 squared is 25. Doesn't matter if the sign is plus or minus, because one is going to be plus and one is going to be minus. Let's try one then where the real part is negative and see what answer we get. So we'll use y equals minus 3 plus 10i. So y bar, its complex conjugate, is going to be minus 3 minus 10i. We'll multiply them. Y times y bar. That will be minus 3 plus 10i multiplied by minus 3 minus 10i. Split the brackets. Minus 3 on minus 3 minus 10i on that, and then plus 10i. That's plus 10i on the second bracket. Minus 3 minus 10i. So now we're going to do multiplying integers. To work out these brackets, we use the rules of multiplying. Okay? If the signs are the same, then the answer is positive. If the signs are different, when you're multiplying two integers, then the signs are negative. So it's a minus by a minus will give us a plus. 3 3s are 9. A minus by a minus will be plus. 3 10s are 30i. A plus by a minus will be minus. 10 3s are 30, and we still have the I. A plus by a minus will be minus. 10 10s are 100. I times I squared. So leave the 9. Minus 30i plus 30i means no I. And then minus 100 times I squared. So that's going to be 9. We're dropping the I squared. We change the sign here. That's a quick way to do it. Plus 100, which is 109. But again, if you look at this, 9 is actually 3 squared, and 100 is actually 10 squared. So there's definitely a quick way to do these. Right, let's do a couple the quick way. So if I had, say, another z, which is 2 plus 6i, then its conjugate is going to be 2 minus 6i. So z times z bar will be 2 plus 6i times 2 minus 6i, which is 2 squared plus 6 squared, which is 4 plus 36, which is 40. 2 squared, 6 squared. So we have another one, say w equals minus 3 minus 2i. Therefore, w bar is going to be minus 3 plus 2i. And if you multiply the number w with its conjugate, complex, 3 minus 2i times minus 3 plus 2i, we're basically saying 3 squared plus 2 squared is 9 plus 4, which is 13. You know, these minuses are going to cancel out, so you can just say, you could say minus 3 squared, but it's the same thing in the long run. One more. So we'll call y is equal to 5 plus 7i. Then its complex conjugate, y bar, is going to be 5 minus 7i. Y times y bar is 5 plus 7i times 5 minus 7i. Right? Basically 5 squared plus 7 squared, which is 25 plus 49, which is 74. That's it. Thank you.